Jiayang. So, today we're going to learn how to solve a system by using substitution. Yesterday we used it by graphing. Today we're going to use it by substitution. And our objective today is, given a system of linear equations, students will be able to find the solution by substitution. So, let's do a summary of this unit real fast. It's all about systems. So this unit we're just going to focus on systems. We're going to learn 3 ways to solve a system: graphing, substitution, and elimination. We already did graphing. And review real fast what's graphing. You graph one line, you graph the other line, you're looking at where they cross. Graphing's good in the sense that you get a visual representation of what you did, but at the same time it's not very accurate like you did all yesterday. You're going, oh, what is it about? You're estimating how close it is. So we're going to do more accurate stuff today. We're just going to work on substitution today. And then tomorrow you're going to work on elimination. So let's work on substitution. Before we work on substitution, let's talk about the idea of substitution. A lot of times I tell you after you finish a test, substitute the answer back in. Plug it back in to see if you get the right answer. And that's the idea of substitute. Substitute is replacing something with something else. For example, if I'm absent, like on Wednesday, someone would have to come and replace me. That's called a substitute. Someone of equal value come in and take my spot. For example, if I have 3x equals 6 and I say x equals 2, that means every time I see an x, I can put a 2 in a spot because they're equal value. X equals 2. I see an x right here, I could take that out and put a 2 there, so 3 times 2 equals 6. Do you understand the idea of substitution? Now let's look at 2 lines. We have a line here and a line here. We could graph it and look at where they cross, but we're going to show you a different method. It's called substitution. First thing in substitution is isolate a variable. Get a variable by itself, so the variable's alone, like a y equals or x equals, right? If you take a look at this problem, a variable is already isolated. You see right here, y is by itself already, and it's equal to something. So now I'm going to take this idea and substitute it into the next equation. That means whatever y, wherever I see a y, I could put a 2x plus 1 instead. I see a y right here. So take a look. I go 2. I take out the y. Substitute in 2x plus 1 minus 3x equals 3. That's substitution. Now, we have one equation, one variable. We could solve for this. Distribute 4x plus 2 minus 3x equals 3. Combine like terms. 4x minus 3x is x plus 2 equals 3. Minus 2 both sides, x equals 1. Now, what am I really finding? Remember, I'm finding where 2 lines cross. So this is not my answer. My answer is actually a point, x and y. I found the x, so how do I find my y? So take a look. I'm going to take this answer and plug it into one of these equations. Does it matter which one? No. I suggest plug it into the isolated variable. Plug it into this one right here because it's already solved for y. Take a look. That's going to be y equals 2x plus 1. I know what x is. It's 1, so I'm going to substitute that 1 for x. Y equals 2 times 1 plus 1. Y equals 2 plus 1. Y equals 3. Therefore, my solution is 1, 3. This is the point where they both cross. This is just the idea behind that. And then later on, the camera's not following me. All right. This is the idea behind that, and later on we're actually going to do more complicated problems. But how do I know if the solution's right? Plug it in. See if they actually the solution for both points. If I put in 1 here and 3 here, that means 2 times 1 is 2 plus 1 is 3. Y is 3. Plug in right here. 2 times 3 is 6. Minus 3 times 1 is 3. 6 minus 3 is 3. So plug it in and check your work. I can do that a little slower, but see if you get it right. Alright, the idea is find the isolated variable, plug into another equation. Let's do a little harder one. So the first conceptual problem is always easy. But let's look at more complicated problems. Let's look at this one. Just a little more complicated, and we'll do another one after this. Take a look. First thing first is isolate a variable. Get a variable by itself. So you look, which variable do I isolate? In the first equation, I got an x and a y. In the second equation, I got an x and a y. So which one do I isolate? Take a look. I want to isolate kind of like the weaker variable. Think about it this way. If you're like a burglar, you're gonna go around and find someone who's what? Kind of like alone, walking alone, not with the group, and then you rob them, right? Take a look. You look at the kind of like a variable that's weaker. The variable is kind of like alone by itself. This one has a 2, this one has a -2, this one has a 3, but look at that. That y is alone. So we're going to isolate that y. So take a look. I got a 2x plus y equals 4. Get y by itself. Subtract 2x from both sides. Y equals -2x plus 4. You see now the variable is isolated. Now every time I see a y, I put a -2x plus 4 into the other equation. Every time I see a y, I put a -2x plus 4. Take a look. Take a look. I got a -2. I see an x plus 3. I see a y. Every time I see a y, I put a -2x plus 4. I take out that y, I put a -2x plus 4 equals 4. Now you can solve with just one equation, one variable. -2x minus, distribute, 6x plus 12 equals 4. Simplify, -8x plus 12 equals 4. Subtract 12 from both sides. -8x equals -8. Divide by x. X equals 1. Perfect. Are we done? No, we need to find the other point. There's an x and a y point. So you take this and you want to plug this back into the isolated variable or the other one, your choice, but I found it easier to plug in this one. So y equals -2 times x. X is 1 plus 4. Y equals -2 plus 4. Y equals 2. Therefore, this is your solution. Your solution is 1, 2. How do you know that's the right answer? You plug into the equation, both of them, to see if there's a solution for both equations. How do you guys feel so far? Good? Let's do one more. Let's do one more. A little bit harder. Alright, take a look over here. I want to solve this. Look for the isolated variable. Which one looks the weakest? To me, it looks like the first equation, the x looks the weakest. I think this one looks the weakest right here. So, and I think it's the x. Everything else has numbers around it. So I'm going to solve for x. I'm going to move the 3y over. So -x equals -3y plus 4. How do I get rid of this negative in front of the x? Divide everything by -1. X equals positive 3y minus 4. Now that I have an isolated variable, I'm going to take that and plug that into the other equation. That's going to look like 2. I see an x. I'm going to plug instead 3y minus 4 plus 4y equals 3. This becomes distributing 6y minus 8 plus 4y equals 3. Simplify, that becomes 10y minus 8 equals 3. 10y equals 11. Divide by 10. Y equals 11 over 10. Do I want decimals? No. We're going to deal with fractions only, so you guys practice your fractions. Now I found an answer. What I do with the answer, I plug into the isolated variable. X equals 3 times y. There's my y. I put in 11 over 10. Minus 4. X equals 33 over 10 minus 4 over 1. Common denominator. Multiply 10 on top, 10 on bottom. X equals 33 over 10 minus 40 over 10. X equals -7 over 10. So my solution is -7 over 10 divided by, or comma, 11 over 10. Good. Alright, that's all the time we have for today. Good luck, guys, and I'll see you tomorrow.